Assalamualaikum warahmatullahi wabarakatuh, and I greet to my supervisor, Dr. Adib bin Hamdan, and my name is Amirul Mukmini bin Abdullah Zari. 1614203 is my metric number. The numerical analysis of inhomogeneous Femur finite element model is my final year project title. So the first one is introduction, which is motivation, objective, and problem statement. So the motivation is this project helps to improve more on discussing limitation and the advantage of taking inhomogeneous as part of our main procedure. So the result on every article has different views on homogeneous and homogeneous of femur model. This project will help more people in the future because inhomogeneous is one of the important part to be taken care of. So in this modern days, the technologies are getting better, and it is important that we understand and know how to use the software and application in this engineering world. So about the problem statement is talking about limitation. Homogeneous limitation is that it uses only certain part as average of all other parts, which is they only use one part to cover up all the other part. So the second one is certain region of their part has different properties and changes depending on the condition. So that is the problem statement. So the objective is to revisit elasticity densitometric measures relationship reported in the literature to construct femur finite element model from gauge scale computed tomography CT scan by using LS Prepose. That is the software to create in homogeneous femur model by mapping elastic modulus corresponding to gray scale image of femur representing heterogeneous density to simulate sideway fall on the inhomogeneous femur model and compare to benchmark model of homogeneous femur. So this is part of the introduction. This is discussing about the femur bone, and this is the femur bone. As we can see that femur bone is known as thigh bone. It is divided into three parts, which is proximal, diversis, and distal femur. So the first one is proximal, as you guys can see in the picture. It contains head, neck, and two trochanters and adjacent structures. Femur head, which articulates and with the pelvic bone acetabulum, occupies 2/3 of the sphere, and the neck is 4 to 5 cm long with the smaller front to back diameter and compressed at its middle. So the second one is diaphysis. The diaphysis is the body of the femur bone, and it is like a cylindrical shape, as you can see on the right side, figure 3. The shaft has two additional edge in addition to linear aspera and a lateral and medial margin. So the third one is distal. Distal is the lower part of the femur bone, and it is bigger than the proximal body. So we will go to the literature review. For the first one is inhomogeneous femur bone. As we can see that I'm taking Peng 2 or 3 articles to compare between their studies, which is Peng and Young 2006 and Young 2010. So in this both studies, they imagine about the data relate variation autotropic elastic constant from available empirical relation between bones density and material properties. But in the study of Ashman 1995, it is stated that autotropic elastic constant, although applicable to cellulose bone, but not known to correlate well with the density of bone. That is the problem of between 3 articles or 3 studies between them. So the most study in Peng 2006 has been criticized because a lot of problem that occur in the study. So according to Young study 2010. So the second one is mechanical properties of femur bone. So as we can see in the study of Next 1976, diaphysis is divided into 6 radial region, which is this is how we prove it is inhomogeneous. So we can see that this is the mechanical property of femur bone, homogeneous and homogeneous. This is the difference between Young modulus value between the inhomogeneous and homogeneous region. So for inhomogeneous, we divided it into 6 regions. For homogeneous, we divided it. We don't divide, but we use it as an average to cover all region. So this is the part. So this is, the second one is about shear modulus. So just now is shear modulus, now is shear modulus. So we compare which value is better, homogeneous or inhomogeneous. So the third one is boundary condition and finite element analysis. So as we can see that the tibia was analyzed under two separate load condition in all study: axial compression, torsional compression, and combination axial compression and torsional compression. So as indicated in the Muller, Kager 2001 and J. Harrington 1976, 2450 was added to the tibia for axial loading according to the articles. So we want to see how the femur will react to the external force or applied force is applied on the femur bone. So the boundary, the anatomically detailed three-dimensional solid model of the tibia was transferred and meshed with the tetrahedral element into any finite element software. So the third one is methodology, the last one. The last one is the CT scan and finite element mesh. The CT scan is how we produce or how we create the femur bone using the appropriate software. And as you guys can see, different nodes will be used to investigate the effect of mesh refinement on every region. Mesh are made linear hexahedral element. So the second one is inhomogeneous material model. Material model, each element will have constant elastic modulus and shear modulus regardless of their direction. A sphere unit is obtained from the grayscale CT scan and used to define the density of each bone region according to HU value. So as you guys can see, this is how we calculate, or the formula is used for calculating the average, the density, the number of element of mesh, coefficient of provided calibration. So this is loading boundary condition, the fourth one, which is based on Young 2010 studies. Single force 500 Newton was applied to on the surface of femur head, centered on the scheme local reference to coordinate. So the last one is my conclusion, which is inhomogeneous femur model improves the result significantly, which is, as we can see from my study, from my research, inhomogeneous is important for any experiment or medical studies, because inhomogeneous consists of many regions, which is we can take more average or more result to compare between other results, so that we can have the exact or the correct value to perform any experiment. So inhomogeneous is important rather than homogeneous, because homogeneous uses only average value, so it does not accurate uh, according to the studies and to the other articles between them. So for me, in conclusion, inhomogeneous is important. So that's all for me. Thank you so much to all supervisor and panels. I hope I can do my final year project very well. Thank you. Assalamualaikum.